Welcome to the first of 4 narrated PowerPoints covering the material for Lecture 2 of BBE 4023. The 4 narrated PowerPoints are being used to make the material more convenient for you to review and to allow class time to be used for class activities and answering questions. Lecture 2 topics are related to instrumentation and data handling. Some topics are related to sensor or transducer selection. My guess is that many of you don't think you will be purchasing instrumentation after you graduate and begin your career. You never can tell what you might be asked to do. I had the good fortune of having one of our graduates come back and share a story about her experience in her first job. She took this class, but admitted, when she told me her story, that she never figured that she would ever be purchasing instrumentation. Well, within 6 months of starting her first job, she was asked to recommend an instrument to purchase to measure odors. She told me that her first thoughts were, "What did Dr. Yanni tell us about purchasing equipment?" She did fine and has moved on to another position. The point of the story is that you never know when you might need this information. The material for Lecture 2 is in 4 narrated PowerPoints. This first section will cover significant digits, rounding numbers, and units for clear communications. The second section will cover sensor and transducer sensitivity and the difference between precision and accuracy. The third section will cover measurement uncertainty and measurement error, and the fourth section will cover how to deal with bad data. The way we write numbers communicates the precision of the measured quantity or calculated value, and precision is an important concept and characteristic when working with measured data and statistical results. Unfortunately, the use of calculators, spreadsheets, and computer programs leads many people to use more significant digits in their calculations and writing than is appropriate. This narrated PowerPoint will cover significant digits, rounding numbers, and the importance of units. The purpose of this presentation is to give you clear guidance on how you should write numbers to communicate clearly the number of significant digits and how to round numbers. The number of significant digits in a number indicates the precision of the measurement or quantity. If someone reports that they measured some distance to be 2.039874 meters, they are indicating that they were able to measure the distance down to plus or minus 1 micron, or plus or minus 1 times 10 to the minus 6 meters. That is pretty precise. Are they correct? Maybe, maybe not. It depends upon what equipment they use to measure the distance. It would not be a common practice to measure a distance that precisely. They needed to use some rather sophisticated equipment. Common significant digit guidelines say that all digits are significant except 0. Zeros may or may not be significant depending on the zero's position. In the first number shown in the table, the zeros are not significant. They are important because they clarify the relation between the decimal point and the significant digits. In the second example, the 0 is significant. In the third example, it is not clear whether or not the zeros are significant. Not being clear is not desirable. One way to communicate clearly the number of significant digits is to use scientific notation. In that case, all of the digits, including zeros, are assumed to be significant. Excess zeros should not be written down because they would indicate excess of precision. Another way to communicate values and significant digits clearly is to use unit prefixes and again only include significant digits. The guidelines for rounding numbers that we will use are illustrated in the course packet and shown here. We will round up whenever the digit to the right is a 5 or greater. We will drop excess digits if the digit to the right is 4 or less. This slide shows 4 examples. The first column gives the original number, and the second column indicates the precision of the last digit to be included in the answer. The third column gives the rounded value. Many times you will need to do some simple calculations with numbers with unequal significant digits. In these cases, the answer should be reported with the same precision as the number with the least precision. In the example given, the number with the least precision is the value of 5.0, which has a precision of tenths. The result of the sum should be given with the precision of tenths. A number without units isn't a complete answer. A number does not communicate clearly the result because the reader does not know the units. Is the number a distance? Is the number a temperature? Is the number a weight? Without units, the reader does not know. So include units on all of your numerical answers. Significant digits and rounding numbers are important concepts when trying to communicate the precision of measured quantities. The course packet has additional guidelines for carrying out calculations with numbers with different numbers of significant digits. Now is a good time to develop good habits for handling significant digits and rounding numbers. This is the end of this narrated PowerPoint on significant digits and rounding of numbers and the need for units to clearly communicate numerical results.